In this video we'll be covering the different types of electronic components commonly found in your garden variety guitar effects and learning how to identify different types of components, decode their values, and identify them by their symbols in circuit diagrams. Guitar pedal circuits are made using a number of different components in various configurations to get the desired result, but to achieve that result you'll need to start by being able to tell those components apart. Components you'd commonly see in guitar pedals are resistors, capacitors, transistors, integrated circuits, diodes, LEDs, and inductors. You also have other components such as jacks, potentiometers, and switches to help you control some of the circuit's functions, as well as connecting your instrument and amplifier to the pedal circuit. Resistors are the most common electronic component, and they are found in every guitar pedal circuit worldwide. As the name suggests, they are used to introduce resistance into a circuit, and in their simplest configuration, they are used to reduce the amount of current passing across them by a predetermined amount. The unit of resistance, ohms, can also be prefixed with kilo and mega for larger values in the thousands or millions respectively. So if you hear somebody talking about a 2 kilo ohm resistor, then you know they're talking about a resistance of 2000 ohms. Likewise, if you hear 5 mega ohms, then that means 5 million ohms. The most common type of resistor you will see in effects pedals is the quarter watt variety, meaning they are rated to handle power levels of up to 0.25 watts. This power rating is ample for the vast majority of the builds you will be encountering. Visually, a resistor looks like a little cylinder with legs at each end, usually beige, brown or blue, with 4 to 5 coloured bands around the body to denote the value of its resistance. The colour of each band represents a number, and the different values are expressed through various combinations of those colours. In the chart below you'll see how the colours and numbers are related. You've got two different colour schemes, one for value and one for tolerance. Value bands are grouped together on the left and follow the rainbow scheme down here, and tolerance bands are on the right and follow a slightly different colour scheme, with each colour representing a different percentage value. Why do we have tolerance? Well, not all resistors are created equal, and as such the true value of each resistor in a batch will vary ever so slightly either side of the value shown by the coloured bands on the body. The tolerance shows you how much that value may vary, and the higher the percentage, the wider the range of potential values. The first two digits on a 4-band resistor are used to get a number, which is then multiplied by the third band to get the overall value. For example, red and green would be 2 and 5. Put those together, you've got 25. The third band is the multiplier and shows you essentially how many zeros you're going to be putting after those first two numbers. If we use orange here, that's a multiplier of 3, so 3 zeros, which is 1000 basically. So that gives us a resistance of 25,000 ohms, or 25k. 5-band resistors have a third band before the multiplier and usually have smaller tolerance ratings. Most 5-band resistors are in the 1 to 2% tolerance range, whereas 4-band resistors are generally in the 5 to 10% range. As you can see on the chart, there are other superfine tolerance ratings denoted by different colours down at the bottom of the scale there, but the ones at the top are the ones you will generally encounter. This 5-band resistor has yellow, blue and black value bands, which are 4, 6 and 0 respectively. Put them together, you've got 460. Again, the multiplier band is orange, so that's 3 zeros, which means 460,000 ohms, or 460k. Quick side note, small resistance values of under 1k or 1000 ohms, these are often suffixed with the letter R. For example, 460 ohms would be written as 460R. A minute ago we covered how tolerance indicates how much a resistor's true value can vary from the value displayed by the coloured bands, with each colour representing a range in terms of percentage of the resistor's value. So if we go back to our 4-band example, you can see that it has a gold tolerance band which is plus or minus 5%. Meaning this could have a value anywhere between 95% and 105% of the intended value displayed by those coloured bands. 5% of 25 kiloohms is 1,250 ohms, or 1.25k. So the value could be anywhere between 23.75k and 26.25k. Looking at our 5-band example, you see it's got a brown tolerance band, which is plus or minus 1%. This resistor is obviously a 460k resistor, and a 1% tolerance would mean you have a value somewhere between 455.4k and 464.6k. As you can probably guess with the tolerance, you really want to be using smaller tolerance values when using higher value resistors to ensure that you don't have too much variation away from the intended value. You would read the value of a resistor from left to right, but which end is left? The first thing to look for is the slightly larger gap between the multiplier and tolerance bands compared to the gaps between the other bands. The tolerance band should be away from the others on its own, making it a little easier to see. Sometimes that gap is a little hard to pick out on smaller bodied resistors, especially 5-band resistors, and especially if the tolerance band is red or brown, as these are also common colours for the first value band. Bear in mind that it doesn't make sense for factories to make resistors in every value, as retailers would never have the room to stock them all, so resistors are generally manufactured in a number of standardised values at certain intervals in multiples of tens, thousands and millions. Generally, if you read off that value and that value seems unusual or oddly specific, then you're likely reading it backwards. Flip it and read it again and it should make more sense. The only real way to determine a resistor's actual value is to use a multimeter. Multimeters exist in various forms with various features depending on their cost and configurations, etc., and we'll go over these in more detail in the tools, what you'll need and why part of the primer later on in this series. But one of their many uses is to measure resistance. By connecting the probes to the legs of the resistor, this completes a circuit. The meter will then pass a small signal across the resistor, allowing it to measure the resistance, which will then be displayed on the screen. The schematic symbol used to show a resistor in a circuit diagram can be either a rectangle or zigzag, with lines at either end representing the body and legs respectively. On schematic diagrams, resistors are represented with the letter R and usually labelled with a reference number and a value. Well, that about wraps it up for resistors. I hope you enjoyed the video. If you did, then please do the old like and subscribe dance for me. You know the score by now. The next video on the menu will be about capacitors. Be sure to subscribe so you can catch all the videos in this series, and make sure you tell your friends. Bye.